Inverse functions. First of all, let's talk about the definition of a one-to-one function, because for a function to have an inverse, it has to first be one-to-one. So we talked in class about what it really meant to be a one-to-one function. It means that x and y have a one-to-one correspondence. So if we look at the formal definition, a function f is a one-to-one function if, for a and b in the domain of f, both of these situations apply. So if a does not equal b, that means if there are two values in the domain that are not equal, then their resulting values of the function cannot be equal. And conversely, if you have two values of the function that are equal, then the values in the domain, or the x values, have to be equal. Now that may not make a lot of sense to you, but maybe we can relate it to being a function. So remember, for a relationship to be a function, then one x cannot yield two different y's. And remember, we had the vertical line test to test for whether a relationship was a function. So that's vertical line test abbreviation there. Well, think about it this way. For a function to be one-to-one, so first of all, this has to apply because it has to be a function. But then to go a step further, if it's a one-to-one function, then two different x values cannot give you the same y value. And where we had the vertical line test for whether a relationship is a function, we can use a horizontal line test to determine whether a function is one-to-one. But first, let's look at these two relationships and determine if they are one-to-one. So in example 1, we have the relationship that maps 2 to 1, 4 to 2, 7 to 3, and -2 to 1. Is that one-to-one? Is there one x that yields a different y every time? I'm sorry, I said that wrong. Is there a value of y that belongs to two different x's? That's what I should have said. And if you notice here, we have -2 that gives you 1, and we have 2 that gives you 1. So if we use this definition, we can say that f of a is equal to f of b. However, a does not equal b. So 2 does not equal -2. So this one is not one-to-one because it fails this test. Also, if we think about it in this way, there are two different x values that give you the same y value. So 2 and -2 both give you 1. So this one is not a one-to-one function. So it is a function, but it is not one-to-one. If we look at this example here, just mapping, you see that every value in the domain maps to exactly one value in the range, and there's no single value over here that maps to two different values over here. So this one is one-to-one. And again, don't get too hung up on all these definitions. Just think it's a one-to-one mapping. So 1x gives 1y. 1y gives 1x. And just to look at the graph, so like I said, there is a horizontal line test for one-to-one functions. So if we look at this first graph here, it is a function because it passes the vertical line test. Then we have to see, is it one-to-one? Well, every horizontal line that we draw here only crosses this graph in one place. So this one is one-to-one. What about 4 and 5? Number 4 is a function. It does pass the vertical line test, so I cannot draw a vertical line that goes through more than one point. However, it is not one-to-one because this horizontal line crosses here, 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 and here. So this is not one-to-one. And finally, this one is a function, and it is also one-to-one. If I drew in some horizontal lines here, they're only going to cross that graph once. So this one is one-to-one. Now this is important, defining what it means to be a one-to-one function, because in Unit 4, we're going to talk about the inverse functions, exponential functions, and logarithmic functions. And for a function to have an inverse, it has to be one-to-one. And this is why. So to determine whether two functions are actually inverses of each other, we're going to let f be a one-to-one function. Then g is the inverse of f if the following conditions are both true. So if we compose f with g, we get x for all x in the domain of g. And if we compose the other way around, g with f, we also get x for all x in the domain of f. So what we're saying here is that we start with x, we put it in the function, then we compose it, we land back at x. So f is undoing whatever g did. But the opposite has to be true. If we start with x and put it in f, then when we put that in g, we wind back up with x. So not only does f undo what g does, but g undoes what f does. And if both of those are true, then we have inverse functions. So in other words, two functions are said to be inverses of each other if they are the reverse processes of each other. And we have to have this one-to-one correspondence to be able to go back and forth between there. So if we had, for instance, 2 maps to 1, but these two 1s map to 2 different x's, so there wouldn't be a reverse mapping in this situation. All right, so let's use this definition to determine if functions are actually inverses of each other. So to determine if they're inverses of each other, then remember both of these have to apply. F of g of x has got to equal x. And when we do the reverse of that, g of f of x, it also has to equal x. So for number 6, problem A, I'm going to do both of these, and if both of these are true, then they are inverse functions. So let's do f of g of x first. So that means f is my template, and wherever there was an x, I'm going to put g of x in there. So 1/3 x minus 2. So now if I distribute this 3 times 1/3 would just give me 1. So that's going to give me x. 3 times -2 would be -6. But then I can't forget the plus 6. And that's going to cancel my 6's out, which will just leave me with x. So we're looking good so far. So now let's find g of f of x. So now g becomes my template. And wherever there was an x, I'm going to plug in f. So I'm going to put 3x plus 6 in here. So again, if I'm distributing the 1/3, 1/3 times 3 is just going to give me x. 1/3 times 6, well, 6 over 3, or 6 divided by 3, is 2. Here the 2's cancel out, and I'm just left with x again. So because I have f of g of x is equal to x, and g of f of x is equal to x, then f, so I can conclude, and in mathematics we use 3 dots to say therefore f and g are inverse functions. And we'll continue on in another video.